Welcome back, everybody, to another exciting installment here. Still in Chapter 6, so moving on to Section 6, it's titled Rational Exponents. So what a rational exponent is, think about what a rational number is. A rational number is basically a fancy word for a fraction. So a rational exponent is an exponent that you're going to write as a fraction. So definition, an exponent written as a fraction. So as an example, m over n, but n cannot be 0. So if n were 0, that'd make it an undefined fraction. Can't have undefined fractions. Okay, so here's your examples. It says the exponent 1 over n indicates the nth root. So example underneath, it says x to the 1/6 power is equivalent to, it's the same thing as taking the 6th root of x. So if you kind of locate where everything went, the 6 on the bottom in your denominator of your fraction, it's just basically going to indicate the root that you're taking. So you're taking the 6th root. The 1 is just the exponent on the x. So x to the 1/6 power again is the same thing as the 6th root of x to the first. And same thing vice versa, or same thing over here. It says the exponent m over n is indicating the nth root raised to the nth power. So if I have x to the 3/4 power, the 4 again, so the denominator, that's going to be the root. That's the index that comes out front. You're taking the 4th root of x cubed, but you could write it one of two ways. So you can have the cubed underneath the radical, or you can have it outside the radical. Either way, it's still all the same thing. It's still going to be x to the 3/4 power. Okay? So we're going to practice that. Our first examples, it says to just write these in radical form. So the first one is pretty much already done for you up there, but again, denominator gets pulled out front. That's the index. It's the 6th root of x to the first. Okay, the next one, denominator gets pulled out, index, 5th root of a to the first. And the last one, this is the 4th root of d to the 7th. That's it. Okay, pretty simple. Now doing the opposite. So now we're going to write these in exponential form. So number 4, this would be z, and that's already to the first power, so it'd be z to the 1/4. So index comes underneath in your denominator. Number 5, this would be c. Again, it's already to the first, so it'd be c to the 1/8. And then c over here would be to the 5/3. That's it. Okay. The next ones, now we have to actually evaluate each expression. So remembering your laws of exponents too, because 7 and 9 both have a negative exponent. So how this is going to work for number 7, well, you can't deal with negative exponents. You got to make it positive. So to make it positive, you got to move it down. You got to do the reciprocal, but I'd always just say move it downstairs to make this 1 over 81 to the positive 1/4. So once you relocate it, now it's a positive exponent. Okay, so now what are we doing? Well, a 1/4 power, if you recall, what you're doing is you have 1 over, you're taking the 4th root of 81, which hopefully we know the 4th root of 81 by now. So if you type it into your calculator, you should just simply get 1/3 as your final answer. 4th root of 81 is 3. Next one, so 216 to the 2/3 power. Again, what this means, what you're doing is you're taking the cubic root of 216 squared. So one of two ways to do this. I think the easiest way is apply the root first. So take the cubic root of 216, because that's just 6, and now I just want to square that number. So 6 squared comes out to be 36. A different approach that you can do though, what else you could do, you can just square 216 to start. So 216 squared, that was a pretty big number. And then, so 46,656, and now apply the root. So now take the cubic root of, I already forgot the number, 46,656. So now if I take the cubic root of that number, it should also be 36. So if I take the cubic root of 46,656, and it comes out to be 36 either way. So it doesn't really matter which way you do it. Okay, again, I think it's always easier to do the first way, just so you don't have to deal with really large numbers like this. I think it's easier just apply the root and then square it afterwards, but it's kind of up to you. Okay, number 9, like I said, 9 is just like 7, got a negative exponent, so make it positive, move it downstairs. So you'd have 1 over, this is negative 3125, but now to the positive 1/5. So just the exponent becomes positive. It's still a negative value, it's still a negative base, but now positive exponent. So now what we're doing, this is going to be 1 over 1 over, we're taking the fifth root of negative 3125. If I had to guess, I'm probably going to say that it's 5, but if you don't know, again, we're just taking the fifth root of it. So I type in the index, shrink it. We got negative 3125, and it comes out to be negative 5. What do you know? So final answer would just simply be negative 1/5. And there you go. The last one, number 10. So again, if I write this out as a radical, what we're doing, so there's a couple stars next to this one because this one comes out a little interesting. But you're taking the square root of negative 16 cubed. Okay. Again, what I'm going to do first is I'm going to apply the root because I know the square root of negative 16. That's just going to be 4i. So now I have 4i. Again, no more radical because I took the square root of negative 16, but now I have to cube this. Okay, so when I cube the whole thing, I'm cubing each term. I'm cubing the 4 and the I, so that becomes 64i cubed. But now I can't leave I cubed like that. I'm going to break it down just like we did in previous lessons. So if I break down I cubed, well, I cubed is the same thing as I times I squared. Because we know what I squared is. I squared is just negative 1. So this would be 64i times negative 1, making my final answer negative 64i would be my final solution. And there you go. Okay, moving right along here. On to the next page. So just recalling those laws of exponents, remembering how this all works. So product of powers, basically, again, as long as you have the same base, if you're multiplying two things together, as long as the bases are the same, you're just going to add the exponents. So the base stays, the base is still going to be x, but I just add the exponents like you see. So here's an example. If I have x the 1/4, I'm going to use fractions too, since this is all about fractional exponents. If I'm timesing it by x the 5/4, that's going to be x to the 6/4. So again, I'm just adding the exponents. 1/4 plus 5/4 is 6/4. But now reducing as well, that would be 3/2 is my final answer. So always reduce down your final fraction if you can. And then with division, you're subtracting the exponents. So again, quotient of powers, as long as the base is the same, I'm just subtracting a minus b. So here's another example. If you have x the 2/3 over x the 1/3, so it's still going to be x as my base, but I'm subtracting 2/3 minus 1/3, and that's going to be 1/3. So x the 1/3 power would be my answer. Negative exponents, like we already saw, again, you can't have negative exponents. So if it's negative on top, you move it down to the bottom, like you see, to make it positive. If it's negative on bottom, though, you move it up top to make it positive. Okay, just kind of this whole rotation. But if I have x the negative 1/2, make it positive, it's just going to be 1 over x the positive 1/2. Okay, so make it into a positive exponent. You never leave negative exponents in your final answer. Power to a power, you multiply. So if I have an exponent raised to another exponent, I'm just multiplying a times b together. So if you have x the 1/2 raised to the 4/5, so now we're multiplying those together, which would be 4/10. Again, reducing it, 4 and 10, divide them both by 2, we're looking at 2/5 is your final answer. Power of a product, so basically you already have two things being multiplied, that being x and y. Okay, you already have a product, but now it's all being raised to a power, so you basically just distribute that exponent to both terms. So if I have x to, or xy to the 2/3, that's going to be x to the 2/3 times y to the 2/3. Again, you just distribute to each one. And similar idea for power of a quotient. Same idea. So if I have a quotient, if I have a division problem like x over y, all being raised to a, you just distribute to the top and bottom. And then it also highlights too, if you have one whole giant quotient like x over y, all being raised to the negative a, to make it positive, if you flip it around from the beginning, y goes to the top, x goes to the bottom, now it's going to actually be a positive exponent. Okay, and we've seen that in the past. But just to kind of emulate this as an example, if I have x over y, the whole thing's to the 1/2. Again, that's just x to the 1/2 over y to the 1/2. Just raise each one individually to that power. Okay? So now getting to some examples. Number 11, simplify each expression. Okay, so bases are the same. We clearly see in between we're multiplying, so I'm going to keep the base, but all I have to do now is add the exponents. So if I add 2 over 7, 4 over 7, I get 6 over 7, and that's it, I'm done. Okay? One thing I want to point out too is you want to stay consistent. So my original problem started off with rational exponents, so my answer should be a rational exponent. So like for the next example, we have radicals we're starting with, so my answer should be in radical form once it's all said and done. Okay, this one's a little difficult though. There's a few things popping out to me right now for number 12. First of all, you have a radical on the bottom. So we know we have to get rid of the radical in the denominator. Okay, we're gonna have to do that. But you can't just simply just start multiplying by square root of 3 and square root of 3. Reason why, if you look at it, we don't even have the same roots. You have a fourth root on top and you have a square root on the bottom. You can't do that in this case. Okay, some of you might even want to go ahead and reduce down 27 over 3 and just cancel them down, right? Because you know you can divide them both by 3. You might say, well, that's 9, that's 1. There I go. You can't do that. And again, for the same reasoning. So I can't do that because we have different roots. You have a fourth root on top, you have a square root on the bottom. So I can't do that either. So here's what I'm going to do. I'm going to rewrite these to be in rational exponent form. Okay, so as a rational exponent on top, this would be 27 to the 1/4. On the bottom, that's 3 to the 1/2. Okay, so now, again, I do want to get rid of that on the bottom, which I'm going to, but I also need the same base. So we got 27 and we got 3, right? We don't have the same base. So let me rewrite this. 27 is the same thing as 3 cubed. So now instead of 27 to the 1/4, now it's 3 cubed to the 1/4 over 3 to the 1/2. So nothing changed in the bottom. Okay, again, I'm just trying to get that same base. So 3 cubed to the 1/4, well now power to a power, let's multiply those together. Okay, so that would be 3 to the 3/4 over 3 to the 1/2. Okay, so now we're getting somewhere. What I'm going to do next, let me bring that down here, just so I'm not going into the next problem. So 3 to the 3/4 over 3 to the 1/2. Now let's go ahead and get rid of that denominator. So in order to get rid of it, what I'm going to multiply by is basically itself. So I'm just going to multiply by 3 to the 1/2 on the top and bottom. Okay, and that should take care of that on the bottom. So 3 to the 1/2 times another 3 to the 1/2. Again, you keep the base the same, but I'm just adding the exponents. A half plus a half, well, that's just 1. So I have 3 to the first power on the bottom, or just plain old 3. Okay, on top though, again, you're going to keep the base, but now we got to add the exponents. So we're trying to add 3/4 and 1/4. Well, in order to add two fractions, you need a common denominator. So if I'm adding 3/4 plus a half, we need a common denominator, right? So 1/2 is the same thing as 2/4. So if I add 3/4, 2/4, that's going to be 5/4, which can be simplified more. Okay, 3 to the 5/4 power, what you're doing, if I translate this back to a radical, you're taking the fourth root of 3 to the 5th power, still over 3. I can take the fourth root of 5 3s, right? Think about how many groups of 3s or how many groups of 4 3s can I take out of 5 3s? I can take out one group of 4. So my next part, I would be able to take out again one group of 4 3s. I would still have the fourth root of 3 left over because I still have one left out of the 5 over 3. But the whole point of doing that is because these cancel. 3 over 3 is just 1. So my final answer would just simply be 4th root 3. All right? So hopefully you're able to follow all that. I know it's a pretty complicated problem. Honestly, you probably won't see anything too much like this where you have different radicals, like a fourth root with a square root, or like a fourth root with a cubic root or anything like that. This is how you'd have to tackle it. Okay, we can go through another complex problem like that in the future if we need to. But number 13, so b to the negative 5 over 6, I'll change my color, just to make it stand out a little bit more. So negative exponent, I want to make that positive. So this would be 1 over b to the 5/6 power. Okay? Well, now the problem is technically now you have a radical in the denominator. Okay, if you have a fraction, Rational exponent, fractional exponent in the denominator. That means you have a radical in the denominator. So now we have to get rid of it. But easy enough, what I'm going to do is I'm going to multiply actually by b to the 1/6, the top and bottom. If I do that, that's going to get rid of the radical altogether. Because again, if you think about with a multiplication problem, you're adding the exponents. So if you think 5 over 6, if you add to it 1 over 6, well, on top, I'm going to have b to the 1/6, but on bottom, again, that's my main concern, I would have b to the 6 over 6. When you add 5, 6, and 1/6, and 6 over 6 is just 1. So my answer would be b to the 1/6 over just plain old b. You don't have to write 6 over 6. That's just b to the first power. 6 over 6 is just 1. Okay? 14, taking the cubic root. So we're taking the cubic root of each term. We're taking the cubic root of 64, and that's 4. Cubic root of z to the 6, and that's z squared. So kind of keeping that one a little bit easy. All right, at the bottom though, so we have x to the 1/2 minus 2. That's all over 3x's to the 1/2, and then plus 2. Okay. I think it's easier for these last two problems to actually translate this into radical form. So let's translate this. This would be the square root of x minus 2. And then on the bottom, you'd have 3 square root x plus 2. So I think when you see the radical, it helps you to realize what you're going to do. Okay, with the radical, we know we can't have the square in the bottom, can't have a radical in your denominator. So to get rid of it, we learned this in the last section, you have to multiply by the conjugate in order to get rid of that radical in the bottom. So I have to multiply again the top and the bottom. The whole fraction changes. I'm multiplying by 3 square root x minus 2, that's the conjugate. 3 square root x minus 2, top and bottom. Okay, numerator and denominator. So in my numerator, when you start foiling these two together, so starting to multiply, you would have on top here, you would have, that's going to be 3, and then square root of x times the square root of x, so square root of x squared. And then the next ones would be minus 2 square root x. And then my inner terms, that's going to be minus 6 square root x. And then we'd have a plus 4. So there's my numerator. Okay, we'll clean that up in a second. We'll fix things and everything else. On the bottom again, got to FOIL these two together as well. So 3 square root x, 3 square root x makes that 9 square root x squared. And then we'd have minus 6 square root x plus 6 square root x minus 4. Okay, so again, the whole point of doing this is to cancel all the radicals in the bottom, which that happens because, well, these terms in my denominator cancel because they're exactly the same. We just have one negative, one positive. They cancel out. And even more so, in the numerator and denominator, you have the square root of x, both of these, and the square root, or the square root of x squared, and the square root of x squared we know is just an x. So my final answer, let's go ahead and clean this up. We would have 3x on top, right? So 3 and then square root of x squared, that's just x, so 3x. In the middle, if you combine those terms, that'd be a minus 8 square root x plus 4. And then on the bottom, this would just be 9x and then minus 4. And that'd be it. That'd be my final answer. Okay, technically though, like I mentioned, we should actually transition back to a rational exponent since we start with a rational exponent. So just kind of doing one last and final step, we'd have 3x minus 8, x 1/2 plus 4. And then the bottom would just be 9x minus 4. So that'd be my final solution. And I should actually probably state, since I have x in my denominator, that x cannot be equal to 4/9. That's the one number x cannot be. Okay, similar idea too for the next one. So for number 16, again, if it helps you, you can just write this in radical. That's the square root of y plus 2. And then the bottom, that's the square root of y minus 2. So now we have to multiply by conjugate square root of y plus 2. That's the conjugate, square root of y minus 2. So top and bottom, numerator, denominator, start multiplying now. So on top, just starting to FOIL, that'd be the square root of y squared plus 2 square root y plus 2 square root y plus 4. And then on the bottom, multiplying, this would be the square root of y squared plus 2 square root y minus 2 square root y. So we can see what's happening there. Minus 4. So I'm going to go ahead and cross those off. Those cancel. Breaking this down on top, my numerator, On top, we would have y, because square root of y squared again, so that's just y, plus 4 square root y plus 4. On bottom, that's just y minus 4. Okay, one last and final step, again, going back to rational exponents, this would just be y plus 4y to the 1/2 plus 4. And then on the bottom, this would be y minus 4. And again, we should probably state that y cannot be positive 4. That's the one value y cannot be based on my denominator. Okay, so hopefully you guys feel like you learned something new today. Again, you can go from a rational exponent into a radical. You can go back and forth between the two. Okay, now we know that. Got questions, let us know. But otherwise, have a great day.